Welcome to Ask and Learn.
So for this problem, we're given the area and the current, and then I have the density of iron and the charge of an electron. And so for part A, we're looking for the number of kilograms in 1 mole of iron, but that's just the same as the molar mass. So the answer for part A is just 0.0558 kilograms per mole. Then for part B, we're looking for the molar density of iron. So the equation we're going to use here is molar density is equal to the density of iron over the number of kilograms in a mole. And so that's going to be equal to 1.41 times 10 to the 5 moles over meter cubed. Then for part C, we're looking for the number density of iron atoms. And so all we have to do is take our answer from part B and multiply it by Avogadro's number. So that's going to be 8.49 times 10 to the 28 atoms per meter cubed. Then for part D, we're looking for the number density of conduction electrons. And there are 2 conduction electrons per iron atom. And so for this, all you have to do is take our answer from part C and multiply it by 2. And so we get that there's 1.7 times 10 to the 29 electrons per meter cubed. And then finally, for part E, we're looking for the drift speed of the conduction electrons. So we know that current over area is equal to number density of the conduction electrons times the charge of an electron times the drift speed. And so we can solve for drift speed by dividing both sides by n times q. And so we get the drift speed is equal to the current over the area times nq. And we're given the current and the area from the problem. We have them both up here. And then we also know q, that's just the charge of an electron, and we found n in part D. And so this is equal to about 2.2 times 10 to the negative 4 meters per second.